It's Joey. Today, I'm going to show you guys how to do acid-base extraction. So, right here, it shows three molecules. We have cinnamic acid. It's a compound extracted from cinnamon, and it's an acid. P. Toluidine. I'm very bad pronouncing this stuff, forgive me. This is a base. You can tell by the amino group right here. And then over here we have anisole, which is a neutral compound, non-polar. It kind of just sits there, very stable. We have these three molecules, and we're trying to separate them. How do we go about doing this? So the first step in acid-base extraction is you want to put these solutes inside of a solvent that can actually dissolve all three. So if we want to dissolve all three of these molecules, we need a nonpolar solvent. These can be anything from like alkanes to aromatics to acetic acid, chloroform. Most times at Oakwood we use diethyl ether or ethyl acetate. Pyridine is also really popular, but for this one we're going to use dichloromethane. So let me just put that right here. Okay, so I want you to visualize this experiment taking place in what's called a separatory funnel. Kind of looks like that. Kind of looks like the machine from like Cloudy with a Chance of Meatballs. Has a little thingy sticking out here so you can control how much liquid comes out. So right now, we just put everything inside of dichloromethane. We're going to represent it with like the color yellow. So everything is in here, right? Dichloromethane. Let's give that yellow mark. Everything is being dissolved in there. We're just going to make it yellow. So how do we separate one of these from this? Let's separate this base right here. So if we wanted to take this base out of this solution right here, how would we do that? The way we would react with a base is by adding an acid. So remember this, when we have all three of these together, we have to add a strong acid. I'll just abbreviate with SA. So since we added a strong acid, this was our toluidine, right? Well, it's no longer toluidine anymore. This would be like toluidinium chloride. This is no longer going to be NH2 anymore since it got protonated by the strong acid. It's going to be NH3 plus Cl minus. And the way that this would look in the separatory funnel is this. What was our organic layer, which is the yellow on top, right? But now we have this aqueous layer with the acid at the bottom. So what we do is we pour this out by twisting this knob until we're left with just the organic layer again, leaving us with just these two compounds. Just these two. This is all we want. Cut. Start. So now that we have this compound right here, which was p-toluidine, but now it got changed to NH3 plus Cl minus. How do we get back p-toluidine like how we started? Because now we have this, and we have in a separatory funnel. We also have a beaker full of p-toluidine separately. So how do we get this, which is this, back into what we originally started with? So if it was a base, right? This is a base, and we added a strong acid to turn into this. what we have to do now is add a base to get back our base. So remember that when we're doing extraction, you start with the base, you add an acid, and then you have to add a base to get back what you do. So whatever you start with, you're going to end up adding so you can get back to the original. So if it was the acid, we start with an acid, we add a strong base, and then we have to add an acid to get back our acid because that's what we started with. So if we add our base, this is a beaker. In here, we have p-toluidine, which was a base. Now that we added the strong acid, now become acidic. So we have in here a whole bunch of this acidic solution, physicization with red. But in order to return it back to what we started with, we have to add a base so we can make it basic like how we started. So we're going to add in a couple of drops of our base until we can get it to back where we started. What that does is it gives us back our original molecule, p-toluidine, and in order to basically isolate it, because it is still in an aqueous solution, we can do something like recrystallization, or we can do um, recrystallization, we can use a drying agent, things like that, in order to separate it. Okay, so now that we've isolated our base, we added our base to get our base back because it was acidic after we reacted it to separate it from these two. And we isolate using recrystallization or by adding a drying agent. We still have our acid and we still have our neutral compound over here. So how do we react an acid? Well, it's literally the same thing as before. We add a base. So let's do that. Base is going to be the color pink. I don't know why, but in my mind, base is pink for some reason. So that's what we're going with. So we add our base, and then what this is going to look like is in our separatory funnel, it's going to look like this. Have our organic layer. In here is going to be our neutral compound because our neutral is neutral. It doesn't go anywhere. No matter what we add in there, it's not going to move. But what is going to move is that acid. And that acid is going to be in that bottom layer called the aqueous layer with the base. Because acids and bases react. Neutrals don't react. This is the acid, and they like reacting with bases. So it's going to be in this aqueous layer down here, isolated. This is what we want. This is the whole purpose of the experiment. This happens, that means that we're winning. So we add our base, and what that does is that takes our acid and makes it basic. So this group right here, this OH, we're just gonna wipe that off because that no longer is a thing. And we're gonna adjust and change that. This is now O minus, and you're probably gonna have like a Na plus right here. So we're using NaOH. That's the base that we're using. So now that it's basic, we basically isolated everything because in this, what's left up here is the neutral. So by separating the acid from the neutral, we also separate the neutral as well because they're on two separate containers. So now we have two beakers. A beaker that had our once acidic, now basic solution of cinnamic acid, which is now basic. And then we also have our other beaker. We just isolated with our neutral and the organic layer. We just poured off. So now this separatory funnel is now empty. So this is now just looking like this. It's empty. There's nothing in there anymore, which is great. That means that we're almost done. So now that we have this compound, which was our acid but is now basic because of the base that we added, how do we get it back to the acidic form we had at when we just started? The way that we do that is by adding an acid. The same process we did over here, we're doing right here. So let's add our acid basic group and replace it with this acidic group right here, just like how we started when we began this experiment. And over here, all we have to do is just purify this by distillation. We can just distill this and we'll get our neutral. So we can also use crystallization, or we can use a drying agent for this. And this is basically all the steps to acid base extraction. I hope this cleared things out. If you have any questions or anything, text me. Um, yeah.